Hello, everyone. Welcome to the finals edition of RIG. Glad to see that at least some of the students and faculty folks could make it here. And for those of you who are watching later on the recording, we're glad you're catching up and hope your test went well. We have a pretty full agenda today. We have three speakers who are going to give us two speakers who are going to give us project updates and another edition of our paper reading group, which people were pretty interested in the last time. So we're doing 2 out of 3. And then we also have a special announcement from the DevConf US folks who have come here to let people know about an opportunity with submitting proposals. So with that, Urvashi Mohani, if you would take over, that would be great.
Sure. Thank you, Heidi. Hello, everyone. I'm one of the organizers for DevConf US, and I have Sally here as well, and Langdon. So DevConf US is a developers conference that we have every year. This is the 4th one in the US that we're doing this September. It's going to be on September 2nd and 3rd, and it's going to be an online event, which will be happening on Hopin. So if you happen to attend it last year, it's very similar to what happened last year, and we're hoping that next year will be in person again. So the CFP for DevConf is currently open, and it's open till the end of May, so till May 31st. And we are definitely looking for a lot of talks. So please take a look at the CFP. There are various options. You can do a session, which is a regular presentation. You can do a discussion. You can do a workshop. So we have multiple options for everyone there. So if you take a look at our website, devconf.us, I can paste it in chat over here. You will see the various topics that we have in mind. And even if your talk doesn't fall under that topic, we have like an other option as well. So just wanted to see any of the cool stuff you've been working on, any cool open source projects and all. So please take a look, and please spread the word to your students and all of your faculty and to your friends if you're students. So we highly encourage new people for this conference, since it's supposed to be a very small, low-key conference where new people who are new to presenting get a chance to take a stab at it, basically. Did I miss anything, Langdon or Sally?
No, I don't think so. It's just that it's a great way to get your first tech conference under, speak at your first tech conference, which I obviously need to do.
Yeah, you might have said this, but I'm not sure. DevConf US, if you're unfamiliar with it, like the other DevConfs, the idea of it is it's your first speaking opportunity. So there's a lot of infrastructure support for that. So there's speaker coaching. It's also encouraging your first attendance of a technical conference. So there's even attendee coaching. So like, what should you do if you go to a conference? What is a hallway track? All those kinds of things, which can be kind of daunting if you're going to, like Red Hat Summit, where there's, you and 8,000 of your closest friends. So, keep in mind, like, if you've never done this kind of thing before, you're the person we're looking for. So please submit your talks. And then we also try to favor and support, kind of underrepresented speakers. And so underrepresented, maybe this is your first time, but it could also be that you're not typically found in the software world. So, we do try to favor those kinds of people into the speaking roles. And then obviously anybody can attend because it's free. But we do try to, like I said, we try to pair people up with coaches. We try to provide a lot of support. We do have abstract support in the works, which we normally do, but kind of dropped the ball and completely forgot about this year. So we're putting that together so that we'll have it, so that if you need any help with an abstract. On the flip side, if you have any concerns whatsoever and you do have an idea for an abstract that you want to submit and you're not sure if it's a good one or whatever, feel free to reach out to me, to Urvashi, to Sally. Yes. Basically, there's, Heidi, I'm sure would be happy to help. I'm sure there's a number of other people would be happy to help. We are excited to have more speakers because then we get to not have to do all of the talks. And that way we can have other people do some of the talks. So please just ask for help. We all had to learn at some point. It's not embarrassing.
You can also reach out to info@devconf.us. I put in the chat, and that goes to us organizers as well. So with any questions or concerns.
Yeah, it's a fun conference, and anybody who's presented at a rig already, you already have, some slides together and an abstract. So I encourage you to go for it. Thank you very much, Urvashi and Sally and Langdon. We're going to move on to the next topic, which is a project update from Gabbie Chang. She was an intern here at Red Hat and still is an intern here at Red Hat. And she's going to update us on How Do You Fedora.
Hi, everyone. I'll start presenting. Cool. Let me know if you guys can see this. Okay, cool. Hi, guys. I'm Gabbie. Last summer, I worked on Friendly Fedora, and this year, I got to be on the community platform engineering team, where I worked on the project I'm going to be talking about today. And over the summer, I'm super excited to be on the research team working on a podcast. So a little bit of background about this project. So Fedora contributors all believe in these 4 foundations, which are freedom, friends, features, and first. But although there's a lot of great minds, not all of them think alike. So the idea is that anyone who wants to contribute can have a role, whether it be in engineering, design, translation, whatever. There also exists a magazine series called How Do You Fedora. An example of what one of the articles looks like is this. And in the introductory paragraph of all of the articles, there's a little blurb, which I think perfectly describes what the series is all about, which is that the series profiles Fedora users and how they use Fedora to get things done. So what I worked on was a video series, which is sort of a new video option for this How Do You Fedora series. It's going to profile Fedora's contributors again, and then share how they use Fedora. So this is meant to be an option for interviewees instead of replacing the original series, just for those who feel as if maybe their personality is going to shine through more in video, or they're the type of person who likes to show, not tell, or maybe they just want to record themselves answering questions and writing out all those answers. And in an era where maybe in-person events are not the most practical, this is just another way for that COVID-era connection, meeting some fellow contributors. And the idea is that these would be posted on the Fedora Project YouTube channel and be sort of a take-home assignment. So interviewees, or those who are nominated on their own time, could record themselves, send the clips to the editors who would edit the videos and then publish them. So I thought we could talk about some of the design stuff first, because that's the most interesting in my opinion. So we wanted, I guess I wanted a very consistent video style, just because I thought that would look a lot more professional. And so there's gonna be a lot of bullets on the screen. You don't have to look at all of them. But beyond the basic logo and titles and thumbnail images, I thought one of the things that'd be really important are sort of pop-up graphics to explain some of the acronyms that people use. And I'm sure those who are in Red Hat or familiar with Fedora know that there's a lot of acronyms that people like to throw out. If I said HDYF, I wouldn't expect any of you guys to know immediately that I was talking about, that How Do You Fedora series. So, graphics to explain what people are saying, things like that, what we wanted created. And so we wanted the design choices to be super playful and fun. This is not meant to be some boring interview that's like 20 minutes long and someone has to force you to watch it. And this was really Kyle Conway and Mo. They have a lot of expertise in sort of the design realm. And so we would communicate back and forth sort of our ideas and then work upon each other's and just create a ton of mock-ups. So on the left, that's a graphic that Kyle made, where we were discussing the logo that we wanted to create for the series, and we talked about everything. I thought all of those looked fine, but according to Mo, that green is too stark of a contrast. I don't like that. Let's use pink. Oh, well, the pink, I think it needs something extra. Let's add a border. So there's a lot of back and forth talk and lots of iterations of the assets. It wasn't just someone would create something and be done. And on the right it's a GIF of one of the videos that I made, where when talking about an idea, a lot of times people can just have a different interpretation of what that's going to look like in video format. And so, for example, I was describing how I wanted quotes to be highlighted somehow if they were super impactful. And the way I was describing it, I felt like no one was really understanding what I meant. And so I just sat down and I filmed myself. And then I made a shoddy edit of, I was like, oh, this is what I meant. And then from there on out, we were able to build upon that and work with that and then develop some I don't know, better designs. And here's just another example of just sort of that back and forth feedback, as well as mockups that were created. We entertained all ideas. Another thing were badges, and this is really fun because a ton of interns got to work on these. I think the issue was flagged as sort of an intern issue, and so we had a ton of people working on this, and it was a lot of fun because, again, I thought that all of the badges looked great, but Mo and Marie, for each of them, had a list of, here's 10 things that you did wrong, please fix them. So you can see those are just some of the amazing badge ideas that we got. So I wanted it to be very, very clear for people who are being interviewed on how to film and submit their videos, as well as people who are editing the videos to be able to edit them in that sort of consistent style. And so the idea is that we wanted a complete stranger to be able to either be the interviewee and send their clips in the way that we wanted, or someone who's editing and maybe they've never seen one of these videos, they should be able to produce a video. So we wanted just really clear instructions. And the way that we created this was more of a waterfall method. So I had Marie be my guinea pig because she was the first person that we interviewed. And so before we'd even filmed anything, I wrote out a document and I said, here's how I want you to film your clips. Here's how I want you to send them. Okay, Marie, can you try following this? And then let me know if there's any pain points or if I wasn't clear in a certain part. Just let me know, and then I'll edit them, and then we'll move forward from there. And so I don't know how helpful this is, but the point is just to show you how there's a bunch of different sections where we kind of thought of everything. We're like, oh, for the thumbnail image, people might not want us to take a screenshot of one of their clips because it might not be flattering to them. Okay, let's make sure that they know they can send us a thumbnail image if they want to. Or if you're an interviewee, you should know that you shouldn't spend more than 2 minutes on these questions. So let's make that super clear. Okay, so within those guidelines, those instructions, there's a bunch of video examples to show what to do and what not to do. And so, for example, in the How Do You Fedora series, there is a portion where interviewees sort of share what their desktop looks like. And I thought, okay, there's 3 ways that you can do this. You can have the interviewee stand next to their desktop and just film themselves showing everything off. Or you can have them send in images that they've taken of their desktop, and then they would just describe what's going on in that image. Or the third option is that they could screen record themselves with their actual desktop. And even me just sort of describing that to you, that was just a lot. And that's, and maybe you don't know exactly what I meant by that. And so these video examples are just there to make it super crystal clear. Okay, here's an example of me showing option number 1. Here's my monitor. Here's my super fancy mouse. I don't know. And then on the right is just an example of, at the time, my neighbors were doing construction. And so it was an example of what not to do, basically. If you're an interviewee, don't film when it's super loud, in a super loud environment. Don't wear the same color as the background. And I find it hilarious because I was filmed in the middle of winter, and now it's 80 degrees all the time, and I'm sweaty. Okay. Okay, and then also alongside the videos, I mean, we really tried to think of everything. So for accompanying blog posts, there would be the video, and then we wanted to have a little description that was standardized again. So it'd say, here's a funny portion that's going to entice the reader to watch this video, and then a blurb that says, this is part of an ongoing series, and I'm going to explain what this series is. It's How Do You Fedora. So there's the video descriptions, for the YouTube description, there's blog post, and then even for that funny little summary, intriguing portion, we wrote down some examples. Oh, and again, the idea was that, so someone could pick this up and see, okay, here are some examples of how this should be written. I can do this. Okay, so from this project, there are a lot of takeaways that I got, and the first one was that sort of showing and not telling is essential for virtual communication. A lot of the times, as I mentioned before, I would communicate some idea that I had, and then when people didn't immediately know what I wanted, I'd be like, come on, I just described exactly what I wanted. When in reality, that makes sense. Everyone can interpret a certain instruction in different ways. And so there were a lot of mock-ups that were created. I sat down a lot and said, I don't think you guys understand, I kind of want, when speakers are saying something like this is what the title should look like. And so I would make some scrappy, kind of ugly example. And then from there, people were able to work off of that or gain a better understanding of what I meant. Another takeaway is that there's a lot of experts out there, and I really owe it to the design team, because for me, a lot of, I talked about earlier the badges, they looked great. I thought that the logos that Kyle created initially, those were great. But, Mo and Marie were super helpful, and they nitpicked so much in the best way possible. So everything ended up looking great. And finally, one of the takeaways was that there was a lot of waiting and patience involved when asking an interviewee to send their clips. In order to be nice and give them plenty of time, I'd say, okay, have your clips sent in by the end of the month. And then by the end of the month, they're working on the F34 release, and life gets in the way and they're busy. Okay, you can have another month. Get it to me next month. And so a lot of the times, I'd just be sitting and kind of waiting on people to send me their clips or send me their blurbs, things like that, as well as with the design as well. You don't create a badge overnight. There's sort of that whole process where someone creates something and then they get critiqued and feedback and then continue, editing and so on. And I thought it'd be fun to talk about some of the other parts of my internship besides the project. So as part of the community platform engineering team, that was super sweet because I felt like I was at the forefront of everything. And it was the first time where being in a big team, learned about sort of the agile methodologies and Miro boards and things like that. I got to, lead one of the book clubs for the quarter, so that was super sweet. There was also that Fedora Women's Day conference, and that was super fun. The virtual version of the annual event, and I got to talk about sort of my Fedora experience and ideas about diversity and inclusion within the Fedora project. I also totally butchered. They make you say something at the very end in a foreign language, and I remember I had to ask to do it again because I totally messed it up, and it was embarrassing at the time. I guess funny now looking back. And then I also got involved with writing a little bit of blog posts for the Fedora magazine. I mean, obviously the How Do You Fedora series, and I'm still waiting on people to send me their clips so I can finish more of these, but that's a work in progress. Yeah, I thought I would finish it out by asking if anyone had any questions about my experiences with the Fedora community, or internship stories, future plans, or anything about this project. I see someone in chat who said something about waiting for Fedorians to finish things. Yeah, and I think that's a lesson that I am going to carry on into this summer. So I've been tasked with creating sort of a research podcast to highlight the really interesting stories and research that's going on at Red Hat. But one of the things I've definitely learned from this project that I'll carry from there is to create sort of deadlines. If you tell someone, hey, I would really love to have you as an interviewee, can you send me your clips soon? You know, you might not get your clips soon. And so maybe saying, okay, I'm going to ask you to send them by, the end of 2 weeks. I don't know, in 2 weeks' time, can you please send them? And then I think also following up is important. For the written How Do You Fedora articles, there are people who I asked, someone in my team nominated you and said that you'd be a great interviewee for this magazine series. Would you be interested in participating? People oftentimes respond in less than a day and say, yes, that's so cool. That's so nice of them to nominate me. And then I end up chasing them for months to get me to to get them to answer those questions. So yes, that is something that I've experienced. And yeah.
Well, thanks, Gabbie. That was really interesting. And it is exciting to get to do all that in an internship. It's awesome. I bet you have more sympathy for your teachers now too, right? Having been on the other side of trying to collect things.
Yeah, definitely. And especially I have a greater appreciation for the design team as well, just because they communicate a ton about their ideas, and it's super rare sitting in some of the design team meetings. It's super rare for an idea to just get the okay immediately. There's always some, or usually more than some, sort of like critiquing or feedback that's going on, and it's really cool to see how the wallpaper for the new, I don't know, F-34, it's like a water droplet. Remember in one of the design team meetings, they were talking about how Mo actually took that photo and she tried 10 different ways, 10 different drops, and then she moved to a different part of her house to get different lighting, and it was really neat.
Okay, well, if anyone wants to follow up, you can reach out through the notes or through the Red Hat contact page. We're going to move on now to Ahmed Sanaullah, who's going to do our second paper reading group presentation in an abbreviated fashion in 20 minutes. I'm sure there'll be lots of extra content too, so please go ahead, Ahmed.
Thank you, Heidi. I'll try to keep it a little less because I think there's a talk after me as well.
Yes.
So I'll speed this up. Let's see. All right. So I got to ask, are you seeing the screen with the research paper reading group written on it? Yeah. Because Blue Jeans kind of switches it up. So I select this and it shows that one. Anyway, so welcome everyone. This is pilot session number 2 of the research paper reading group. Just to remind ourselves, last time we looked at what research papers are and the value that they offer. And in this session, we're going to take that discussion forward, and we're going to look to answer a very fundamental question when it comes to research papers, which is, how do you find a paper that's worth reading? And what makes this a difficult question to answer is that it's not always a question of good versus bad. You could have 2 excellent papers in front of you, and just because of the time it takes to read papers, you might not get a chance to read them both properly. So you got to pick one. And so what I'm going to do really quickly in the first part of the session is to just go over a list of about 15 things that I use to tell me if a paper is worth reading, or rather to prioritize a paper over another. There's no exact science behind it. This is fairly intuitive, and this is something that I've come up over time. And as you look at this over time, when you read papers, you might end up adding things to this list, removing it, modifying it, etc. So let's just get into the list. The first and the most popular one is, of course, the citations. More citations typically mean a higher quality paper. But of course, there is some inertia involved to citations if they accumulate over time. If you publish a paper at a time where the topic is very popular, you might get them really quickly as the paper on the first paper up there. But as you see with the second paper, they published about 15 years ago, and it took them all this time to start accumulating the citation. And they're still behind the first one, even after 16 years. So this tends to happen. So if a paper is popular today, and you see that it doesn't have enough citations, that's a paper then you would not prioritize versus someone that does actually have them. Let's see, the year is important because latest papers tend to use the better technology, the more modern methods, and sometimes a limitations or a contribution identified in a previous paper might just get fixed automatically due to innovation over time. So latest papers tend to be given more weightage. Sometimes certain authors have a reputation for publishing good work. So for example, if you look at these two authors here, if you were having papers from these two authors, you would most likely prioritize the paper from the author on the left than the one on the right because of how their citations are growing over time. Then the venue, as we discussed last time, is important because certain conferences and journals are more prestigious and thus have higher quality work published there. The abstract is important because the title can sometimes not be that explanatory, so that the abstract helps you get whether this work is relevant to what you're looking for. Specific contributions then take this one step further and say, well, here's a problem that I'm trying to solve. Is this type of solution what you're looking for? And then because research tries to solve a very specific problem, you make some assumptions about the state of technology. The question is, are the assumptions being made valid? Are they being made in a way that makes the entire thing impractical? So you have to look at what assumptions the paper is making in order to make their contribution. The next one again follows this whole concept of specific problems. If you have solved a big problem, chances are you will not need that much text to explain why your problem is worth solving. But if you've solved something that's very, very constrained, then you will need a lot more text and a lot more pages to frame the state of the world to a point where then your contribution starts to look very relevant. So that's another measure. Then the scientific process, if there's a paper that has outlined a way in which they did some experiments, they developed a hypothesis, they tested this out, they built implementation, they tested it out, and then they discussed it, that would be a better paper to read than a paper that says, here's a problem, and I just saw the solution in a dream, and here I've implemented it. So this is an example from last time where we had a paper that had followed a very nice scientific process. Then system diagrams. So most good papers in computer science and architecture should and do tend to have a block diagram that explains what the system is. The more diagram like this, the better, because if they've gone into details about these individual blocks, it helps you understand better what's going on and reconstruct the system. But generally, all good papers should and do have a diagram like this. And then the more figures, the better. More figures mean that you have done a lot of work and you want to illustrate a lot of the different pieces to what you've done, and that generally indicates a more quality paper. Then experiments are important, not the actual experiment done. Or actually, no, this one is the actual experiment done. Sorry. So if you've done a lot of experiments, it shows that you build something proper, and then you're able to test it with a bunch of different inputs and corner cases, versus if you just hacked something together and it only worked for, let's say, one application. And then the testing environment. So testing something in simulation is not as impactful as testing something in real hardware, because testing something on real hardware has its challenges. And then formatting, that's a simple one, because there's so much internal review that happens that for good papers, the formatting typically tends to be good, versus these mistakes with the columns and the figures being too small or the axes not being labeled. And then finally, if the code for that paper's technical contribution is open source and reproducible, that really lifts the credibility of the work, because that means that you can not only read the paper, but you can test things out and see for yourself that, yes, this is a valid paper with valid contributions. So that was my list. What I've done is I've got 3 papers lined up here. I don't think we'll have time to do all of them, but we don't have to do all of them. So the links are there as well. These are 3 papers that I picked up in a field that I'm sure a lot of you have not seen before. And that's perfectly fine. And that's the point. This will be papers where you will not be looking at the detailed technical content. Rather, we'll be just taking a high-level view of what's going on. And we're going to try and fill in this table here. And what we're going to try to do is to see on a scale of 1 to 10, how do these papers rank, and then try to prioritize them against each other. And so what I've done is I filled in some of the fields, like the citations and the year, and some of the more technical-centric content, like the abstract and the contributions. So what I would like to do for the next 5 minutes is anywhere between 0 to 3 volunteers. And I think we only have time to do paper 1. So if nobody volunteers, I'll just fill this in myself. But if someone does, one person does it, they get to be the average score. If 2 people do it, they can be R1 and R2, and I'll be R3. And if 3 people, then, so just put it in chat. If you're interested, put your name in chat, and we'll go through these one by one. I'll give you 30 seconds because that's all the time we have. And then I'm filling this in. Perfect. We have 2 people. Can we get 1 more? And perfect. We have 3 people. All right. So here's what we'll do. So open up the first paper. And what I would really recommend is open up the link in Google Scholar as well, so that you can have a look at the authors, because the first thing we have to fill in is, what's the organization and where would you rank these authors on a scale of 1 to 10? And sorry. And you don't need to look at all the authors, just look at the first or the last one. That should give you a good indication. So I just need from the 3 volunteers a number between 0 and 10 each. And again, you can put it in the chat, and I'll add it to the table. Give me a number. Even if you've not looked at the author, just give me a number so we can move on. Come on. We only have about 3-4 minutes. 8.
No pressure, no pressure.
7. Alex, we're waiting for you. 7. Perfect. All right, let's look at the venue. So the venue for this was ISCA. So if you just do a quick Google search to find out what the ranking for ISCA is. Does it seem like, really good place? We got 10. Gabbie, waiting for you. There you go. All right, so next, let's open up the paper and have a look at the length of the introduction. How many pages does it take for them to go, have to cover both the introduction and, yeah, just the introduction? How many pages? So give that a rank. If it's, 2 out of 10 pages, that's a 10. And then scale that out accordingly. We have a 7 and 8 and 7. Perfect. Do they have system diagrams? Something that explains what them? No, you're fine. This is an estimate. This is just an estimate. You don't have to be exact, spot on with this. So do they have a system figure? Something that shows the different pieces within what they've made. And how detailed is it? Perfect. And Mike, we're waiting for you. 7. Perfect. Okay, let's see. Now, are there a lot of figures in the paper? 7, 9, and 7. Perfect. Next one. Are there a lot of graphs with results on them? Like performance or latency or something. How many results have they shown? You don't have to read the text. Just look at the tables and the figures. Perfect. And the last one, formatting. How well formatted is the paper? Do you see anything that stands out? Yeah, -1 for graphs without axes. You gotta label your axes, folks. And I've been guilty of not doing that on more than one occasion. So last one, formatting. Perfect. So we're starting to see, we did this process, and fairly quickly, within 5 minutes, we were able to fill this in and get an estimate of how good this paper would be. And we're seeing that, we're getting some very high scores there. The testing, and there's some things that I pre-filled in that weren't so good, but other than that, stuff that we looked at right now, it's a very good paper. So definitely, this would be something that you would want to read, and I can confirm that this is one of the really good papers in this field out there. So great. So good job, volunteers. We give you a round of applause, but let's do it virtually. It's great stuff. So I will leave this as an exercise for you to fill the rest of the 2 in, and I can give you my opinion on the last slide. Once you do this, is it should be that P1 and P2 are the papers to prioritize, and P3 is the one you would read later on, because P1 and P2 are the major works. And paper 3 is sort of a very specific problem, a very, very constrained problem that they're trying to solve, given the systems in P1 and P2. So great. So this, again, hopefully this gave you an idea that you can look through a paper and really quickly get an estimate of whether this is something that you would want to read, and then spend the next 5 hours reading it if it actually is. So I'm going to quickly finish this up with the last few comments. Session 3, the last session for the pilot, will be on 1st of June, tentatively. And if there's enough interest after that, then we will make this into a proper paper reading group. For the last session, we're going to try and replicate what the paper reading group would actually function like. And what we're trying to do is a new approach. We're just trying to test this out now. This may not be how it's actually done. We're trying to test this new approach to paper reading, where we have explicitly set out parts of the session where we talk about different pieces of what a paper brings to the table. So the homework for our next session is going to be, I would encourage everyone to read one research paper on deep learning for self-driving cars. And what we're going to try to do is we're going to look at 3 points here. 1, what are the problems in the field that are being targeted in active research? 2, and this combines bullets 2 and 3, which is, what is the solution and what is that solution bringing to the table? And then 3, the third thing, which is point number 4 here, what's the limitation of the work? What's the possible future work that we can do here? And what I'll try to do is, as people are, discussing this or sort of presenting their stuff, I will then fill in a table, and then I'll share that with everyone. And what we'll try to accomplish here is to have then this broad understanding of the topic that we have just discussed within an hour, and we'll see, how much have we able to collectively come up with the knowledge that we've been able to put together. So you can, share your responses during the session, but if you don't feel contributing, you can also just use the QR code, and that's the QR code, and you can send in your responses to the 3 basic questions and your paper that you reviewed here as well. Again, the 3 basic questions being, what is the problem in the field the paper is looking to solve? What is the solution? Just a high-level overview of the solution that the paper is trying to do. And then what is the potential future work that the paper has not addressed, but you see being important and relevant soon. And so with that, that's my presentation. Thank you so much for watching, and I hope to see you at the last session. Thank you.
Thank you, Ahmed. That was awesome. Very innovative. And thank you, volunteers. I see that. Oh, Alexander, I thought he ran away because he was so traumatized, but he came back. So yay. I'm going to move on since we're running a little bit late. But if you have comments or questions, you could reach Ahmed at his email or through the Red Hat research website. So with that, I'd like to move on to our last presentation, which is by Andy Huynh, who's new to the research interest group presentation team. Andy is an IBM fellow who's been working with BU faculty and also with Red Hat engineering on a topic related to tuning workloads. So Andy, please go ahead.
Thank you, Heidi, for the introduction. So I'm going to share my screen here. So I'm very excited at least to come out to the Red Hat community because this is the first time that I've been out here. So since I guess this is like an introduction both to myself, but the work that I'm doing, I'm going to talk a little bit, I guess, about the particular problem that I'm working on. So robust Lsm tree tuning is kind of like the 4 words, I guess, that you could use to describe exactly this project. So in particular, this is with 4 other individuals at BU. So Harshal, another student, Maria Terzi is a faculty member at Boston University, and then Manos is my advisor, and also a faculty at BU here. Additionally, some of you guys may know Josh Burkus, the Kubernetes community manager or community interfacer, and he is my IBM mentor. So very fortunate enough to be funded through at least that particular PhD fellowship. So since, let's see here, we only have, so we have about like 15 minutes, so I'll try to like cut through this a bit fast. But feel free to interrupt me at any point in time. Since I know this is usually like a discussion forum, you can feel free to ask questions at any point. But I'm going to try to give at least a high-level overview of the particular problem, and maybe a little bit of like the progress that's been going on. So robust Lsm tree tunings for workloads and resource uncertainty. Okay, so for many of us who have worked at least in databases or data systems, we're very familiar with this pipeline of tuning data systems. Right, so initially you have a particular database and you might want to change this database to fit a particular application. But that application, you'll have some sort of assumptions on your workload. So the types of like queries or expected patterns of queries that you may receive. But additionally, also the resources that this database is going to live in, right? And depending on these workloads and resources, you may change like the shape or like the architecture and internal workings of the particular database that you are deploying, right? And in turn, depending on, you want to optimize for the maximum performance because you may want, lowest costs for deploying your particular database, but then also revenue increases if you're particularly in that sort of business, right? So in particular, I'm interested though in a problem that happens when you actually deploy something to production, right? So in this instance, say for example, I have an Lsm tree represented by some of these squares here, and I'll go a little bit more into exactly what an Lsm tree is for those who are not familiar. And this is, I place this Lsm tree in production, right? And once it actually is in production, I may have a particular workload and a particular finite set of resources that my database actually experiences, right? And this may be like a selection from maybe some of your assumptions, or it may be totally off from the assumptions that you have made initially. And this kind of begs the question, right? How often do our assumptions for workload and also resources available, how often do they hold up? And additionally, how often would we have to retune our systems based off of the actual workload and resources that we may see in actual prod, right? And it's vital to think about these questions because having the wrong assumptions or not really considering the fact that you maybe need to retune your system, you may lose out on both performance, and you may have to pay more, or you just might end up running into situations where you have catastrophic performance issues with your database. Right. So I'm going to split this talk real quickly into 3 parts. I'm going to give like a quick overview on Lsm trees, talk a little bit about a particular tuning problem that Josh, Manos, Harshal, and Maria and myself have been kind of working on, and then also modeling and deploying Lsm trees. So talking a little bit about like the work that's been going on right then and there. Cool. Any questions at all? Awesome. Okay, so for those of you who aren't familiar with Lsm trees, so it's a particular type of data structure, right? And we can kind of split it into 3 parts just to like kind of 3 vital parts, right? We have on the left-hand side a particular number of levels to a tree. So for, very similar to like a binary tree or a B+ tree, each rung of the tree is a particular level. And then we split kind of this data structure between both main memory and then hard disk. So this could be flash or like a hard drive, depending on whatever system you're running it on, right? So in actual memory, so this would be like RAM on your PC, you have something, you have a section of that RAM dedicated to a write buffer, right? And this is how Lsm trees as a data structure in particular handles writes. And then, so as a particular tree takes in a bunch of write requests, right? Once that buffer fills up, we would essentially sort this buffer and then flush it to disk. So now, rather than being in main memory, it's on cold hard disk, but it's also sorted. That way it's easier to retrieve and easier to pick up like a particular key or object that you're looking for, right? And in this instance, we would call like the first buffer to be flushed to disk to be on the first level, right? But as you go down in levels, the runs, as we would call it, or what the level holds actually gets bigger over time. And we call like the ratio between like how much we grow between levels, the size ratio, right? So if I had a size ratio of 2, every level, the amount of data that I'd be able to hold would be doubling. Hence what we get for a log structured merge tree. So you can go all the way down to L levels and you'd have something that's absolutely huge, right? So the number would grow or exponentially, I guess, after each level. And additionally, in order to support writes in a very fast way, Lsm trees have something called, usually utilize Bloom filters. So for as a reminder, exactly, a Bloom filter is essentially just a data structure that says yes or no as to whether or not something is like a particular item is in a set, right? So in this instance, Bloom filters, though, will always be right if it says no, but it has a certain chance to essentially lie when it says yes, right? And it's a very, very small probability in that instance. So these filters essentially help you filter out like the different levels that you may not need to, may not need to exactly access. So in this instance, each filter corresponds to a particular level in your Lsm tree. And this is more or less kind of like most of the moving parts of a particular like Lsm tree. So it's, yeah, you have essentially the buffer size, the filter, your size ratio, and then the particular number of levels. So this is a gross oversimplification. There's usually a lot of extra moving parts that kind of come along with this particular data structure, but it is a very popular, at least storage engine that's used widely in multiple different commercial products, but also open source projects. So I believe even here at Red Hat, Ceph's Blue Storage uses RoxyB, which is a particular Lsm engine for, I believe it's metadata storage, but I'm not 100% sure. But I know for a fact that Ceph uses like an Lsm tree as a part of its like internal structure. All right. Additionally, too, we have, at least in an Lsm tree, different ways of storing things on disk. So there's like a subtle difference between what we call leveling and tiering. So at the bottom here, you may have noticed that like each level has essentially one big, large sorted run, right? And this is what we would call leveling, in which each level just has one big run. And this is particularly better for read operations. While On the other hand, if you were to keep each level separated by the size of the buffer, right, we would call this tiering. So in other words, rather than merging files as they come on each level, you just keep them in their own separate file. And this, in turn, this is colloquially known to be better for writes, just for performance, right? So there's this really subtle balance between kind of choosing one or the other, depending on what your application might ask for, right? So in particular, the Lsm tree kind of environment that we're working with. So Ahmed was talking about specific problems, and yes, I guess in this particular like work, I would fall under that category of like a very particular setting with a very particular problem. But I'm looking at RocksDB as a platform for the Lsm engine that I'm running. So it's an open source. It's an open source engine created by Facebook. We're using like a custom Bloom filter implementation. And then essentially what I've done is just to create a tuning layer that sits on top of RocksDB. So I've taken all this information that that I kind of mentioned at the beginning, which is like workload, kind of system resources. And I have this layer on top that will calculate essentially how to set up RocksDB properly for a particular like workload and resource management. So additionally, the custom Bloom filter is listed over on the right. Monkey, I use this paper a lot as like at least a couple different reference points throughout the talk, but yeah. Okay, any other questions here? I'm gonna move on because I realize we don't have too much time, but that's fine. Okay, so I'm gonna talk a little about this tuning problem that I'm interested in. So when it comes to an Lsm tree, the particular like design space that I'm looking at, we can kind of frame tuning as an optimization problem. So I'm a bit more familiar, like I'm a bit more on the mathy side. So I do like to kind of keep things as like an actual math problem. But what we have here, so if I ignore resources, like resource variability for now, and I just like look at workload as kind of the prime factor when it comes to designing Lsm trees, what is it? I can frame this problem essentially as a minimization problem, right? So if W is the workload, D is the Lsm tree design, phi is the like fixed system parameters. So this would be like caches, and also like, yeah, basically caches, CPU speeds, etc. And then I have some sort of way to calculate costs, which generally, right, maybe latency for most data systems. I can essentially frame this problem as a minimization problem where I'm asking, hey, find me the design that minimizes my latency based off of one, a particular workload W, and two, the particular fixed system parameters. So whatever like system that I'm on, right? And this is like a very classic way to essentially frame a tuning problem. But this has a lot of downfalls in the sense that I am only considering one exact workload, right? So I'm going to introduce something called an uncertainty region in a moment, but this begs the question again, how often do our assumptions hold up, right? So if it's one particular workload, I am over-tuning. So for those of you who are like in the ML community, right, this would be a classic case of essentially overfitting, right? Where I have one data point and I'm basically basing all of my decisions off of one data point, right? And in turn, this data point is not going to be the fixed data point over time, so I may need to retune the system, right? So we can introduce something called an uncertainty region, which, yeah, an uncertainty region. So on the left-hand side here, I have a 3-axis graph, so like some sort of 3D space, right? And say, for example, I wanted to model my workload, and I only wanted to take a look at the percentage of different operations that I had. So in this case, writes, reads, and range reads, right? I could come up, as a designer, I could come up with an expectation on the workload that I would get in my system, represented by the black dot here, right? But what I can do is I can say, okay, although this is my expected workload, I may have an uncertainty region or a bubble around that particular workload. So I might, although I might assume like an even 1/3 split between each of the 3 operations, in reality, when I run into production, I might end up with kind of navigating the space where I, lean towards more writes, lean towards more reads, or lean towards more range reads versus the other 2, right? And this is a very interesting concept because where does this come up in real life, right? So it sounds like a lot of you guys are systems people, so or like systems and kind of cloud computing at Red Hat. So yeah, this can show up a lot in cloud variants, cloud resource variants, in particular when you have multiple tenants on the same node, right? So if I ignore like workload and say each of these access were instead like different resources like caches, buffer size, available amount of memory, having multiple tenants on the same node or multiple applications on the same node could lead you again to essentially having not the exact amount of resources that you initially requested. Additionally, workload drift is also a very common way for you to essentially drift away from your expected workload. So as, for example, having more reads than you expected. And this could be due to like how your application is used over time. So it's very rare that like an application that you have is going to be fixed usage over time, unless it's like a logging application. But even then, you may get more logs, you know, at one point, at one day versus another, depending on like what exactly is going on in the application. So this could be due to like how your users are using it, or just in general, like the demand for how your application is interfacing with other systems. Right. So what I can do then is I can say, okay, I have this classic tuning problem, but I can rewrite this and reframe this now as what we call, at least in the robust optimization community, a robust tuning problem or a robust optimization problem, right? So now I have something called UW, which I say is the uncertainty region, right? And if I'm breaking down this equation here on the right, or at the bottom, it's very similar to the one at the top. The only difference now is that rather than finding the design that gives me the lowest latency for a particular workload, I'm finding the design that gives me the lowest latency over a family of workloads, right? So in this case, W hat is any workload that exists in the uncertainty region. Any questions there? No. Okay, cool. So what exactly, so this equation here, right? This kind of like framing of this problem where I'm now finding the design that minimizes latency across a family of workloads. What is this exactly doing, right? So when we mean by robust designs here is on the right, I have that familiar picture of like the three different types of operations, reads, writes, and range reads, right? And say W0 in this instance is like the expected workload that you would get, right? The expected workload that you imagine that you would receive and you're basing your design off of, right? And I have kind of these two extreme points, W far plus and W far minus, right? If I pick a particular design, D1, for example, I may get a performance curve that looks like this. So at the apex of my parabola, at the like most bottom point, minimal point, at W0, I am of course performing absolutely amazing, right? But as I stray away from that workload, I may lose performance and I actually might increase my latency over time. If I pick a different design, right, it may not be the best at the apex at W0, but you can see that the extremes for D2 are much further down than D1. So I'm at like, no matter how far away I stray from W0, I'm not doing actually too bad. And, you know, the golden, the golden key, I guess, that I'd be looking for, the golden design would be D3 here, where, okay, I'm not doing terribly at my actual expected workload, but I've very little, like I don't change very much over time depending on the different workloads, right? And this is exactly what I'm trying to find. I'm trying to find D3. I'm trying to find the design that basically flattens the curve, as we may be all familiar with in this last year with the pandemic. Cool. So I don't have much time, so I'm going to brush through this section, but modeling and deploying Lsm trees. So one of the things is that when you, for this particular robust optimization problem, accurate modeling is one of the most extreme important things that you would need to do. So this community that does a lot of like systems modeling knows that accurate modeling is extremely important if you're going to do like, if you're going to frame your tuning problem as an optimization problem. So what I have here is a validation graph. So to break down exactly what this is, in red is the model, the particular model that I'm using, so the estimated like cost latency, while the black dotted line in this instance is the actual measured average milliseconds per write. And you can see they're not exactly the same because they're on two different axes, but they both follow a very similar trend, right? And this is actually extremely important for me when it comes to modeling LSM trees and tuning LSM trees in particular, right? Additionally, when it comes to these sort of cost functions, we need them to both be convex and continuous for a lot of like these optimization methods to work. So in this instance here, you can see that yes, the measured cost in black is not exactly it's not actually always strictly decreasing, but the actual model is strictly decreasing, and they follow similar trends, maybe not exactly the same trends. So it's important for the model at least to be convex and continuous, but the measured cost may not exactly reflect the model. But as long as they look very similar, it should be a-okay for you to use these math models to do proper tuning. So how do we model reads though, right, for an LSM tree? In particular, what is it? There are kind of two major like aspects: the memory filter and the levels that we would use. So in this instance, what is it? We use a probabilistic model. So here, so we use a probabilistic model based on the expected number of IOs. And with this probabilistic model, we essentially say that, okay, Bloom filters essentially have inherent false positive rates. And then we also split reads into two different types with, what is it? Empty and non-empty reads. Oh, someone's leaving because it's 4. That's okay. I will, yeah, there's about 2 slides left, so I'll wrap this up here. But we use essentially a probabilistic model where essentially each level essentially has a certain probability for a query to be satisfied at a particular level. And that probability is based off of the size of each level, but also the chance of you actually querying that level is based on the Bloom filter memory, because the higher the Bloom filter memory, the lower the false positive rate would be. Modeling writes in this instance, the two kind of important parts would be the buffer size and the size ratio, right? So write speeds depend heavily on the buffer size relative to the entry because of the fact that the bigger your buffer, the more data you can hold in main memory, so the less that you actually have to flush the disk, right? Additionally, compaction policies play a heavy role for the frequency of writes, right? So again, tiering is always better because you don't have to do some of that sort merging, while leveling is not maybe the best. So we essentially use an IO model in this instance where we kind of average out the amortized costs of write IOs over a sustained period in order to get an accurate idea of how to model writes. And then putting all this together, we kind of essentially have this tuning pipeline where I take a workload in the system, I give it to an optimizer. So in this instance, I developed a Python optimizer, which is about to be open source. I think I have a GitHub repo that's private right now, but I'm planning on just like opening it up in a moment once I clean up the actual code. And it gives a particular tuning platform, like a set of tuning parameters that you can actually deploy on an actual database, right? And this gives you essentially this answers the question of, how accurate are assumptions at the beginning, right? Because we essentially have done a robust tuning. Additionally, the hope is by robustly tuning a database, you don't have to do the retuning as often, right? You don't have to go back to your optimizer to like give you new parameters. You can kind of cut this cycle and hopefully tune once or tune much less. So I have both code for at least like this API, but also the optimizer and the similar repo. It should be open source and available once I clean things up and kind of like get a paper rolling through. So quick closing thoughts here. So LSM trees always do operate in uncertain environments, and it does require robust tuning, which is why this problem is particularly fascinating, but also like very applicable. But because of like these because we're using essentially optimization models to tune this tree, we require very accurate cost models. Additionally, we've been thinking about how do we extend this design parameter to other data structures, because in general, right, like this idea of tuning data systems is not particularly it is not exact to just LSM trees. Like MariaDB, for example, and then also like DynamoDB and PostgreSQL all essentially have different tuning like paradigms that they use. But yeah, I'm working towards promising results. You may see a paper hopefully in the future. And yeah, if you have any questions, you can contact me at either that email or that website. You can find me there. But yeah, is there any questions at all?
Is there another student who's working on testing your optimization in different environments, or is that all up to you too?
It's also actually up to me right now. Yeah. So I have like under the hood, I have other projects, at least with Josh, that we've been talking about for things like log tuning and then also resource, like uncertainty and like resource managements for multi-tenant nodes. And this is kind of like a side project that I'm doing after we finish this up. So at least for this particular LSM tree project, we're basically at the cusp of almost finishing here. So you may see us in the future. And for those of you who are, interested, keep in touch, and I'll definitely let you know the minute that like the first paper comes out. Yeah.
Yeah, definitely. This is relevant to stuff that we do in the Open Data Hub and the Operate First environment. So that would be great to be able to continue. We'll put more of this detail in the website so that people can look at it when there's not quite as much rush. And thank you, Andy, for making it through. I apologize that you had to compress it so much.
Sorry for going over time there, but yeah.
No, that's okay. We've done it before. We appreciate having you share the results. So thanks everybody for attending. We'll see you on the first Thursday of next month, and appreciate your inputs and comments. Thanks. Bye.
Thanks everyone. Bye.